So for this video, we're going to discuss some techniques necessary for evaluating limits. But before we do that, I just wanted to give you these limit laws. So this is a lot of text here. However, all these are saying is that if you have two things added together, their limits are going to add. Same thing with subtraction. If you have a constant, you can pull it out front. Multiplying and dividing can be split apart. That's all these things are saying. I actually got this straight from your textbook from page 105, so you have it in there, but I just wanted to have this out so that you could see it. You don't really need to write all these down, but you can if you think it'll be helpful for you. We'll do some examples and you can decide if you need all these laws written in your notes or not. So for this problem, we have several limits that we're going to have to break up into multiple limits. So for number 1, we can rewrite this as, I'm actually going to put the 3 out front, 3 times the limit of f of x as x approaches negative 2 minus the limit of g of x as as x approaches negative 2. So in order to do this problem, we are going to first look at the f graph. So I can just pull my 3 up front. I don't need to worry about that. So the limit, I'm going to write this kind of up at the top, of f of x as x approaches negative 2, that is going to be this value right here, which will be 1. The limit as x approaches negative 2 of g of x is going to be this point right here, which is negative 1. So in the end, my answer for this is going to be 4. For number 2, I have the limit as x approaches 1 of f of x plus g of x. You might see an issue here. So with the f of x, that's totally okay. It just ends up being 2. But the limit of g of x as x approaches 1 does not exist. So actually this sum also does not exist. All right, number 3, we are going to be multiplying, and you're going to find that I'm just going to multiply 2 limits together. This one is pretty straightforward because there's nothing weird going on at x equals 3. So you'll find that the limit of f of x as x approaches 3 is going to be 0. It's this point right here. And for g of x, it's going to be 1. So my answer will be 0. So I know that there's a lot of writing here, but this is some really important stuff that will hopefully help you out. So whenever you take a limit at a number, you should always start by using direct substitution. We talked about that in the last video. You just substitute in the number, basically. If you get an indeterminate form, such as 0 over 0, then we're going to use other methods to evaluate the limit. I'll show you those in just a minute. So if you don't know what I'm talking about, I will explain that in just a moment. If you get a number that is not 0, I called it C, but if you get any constant that's not 0 over 0, then the limit is either going to be one of the infinities or it will not exist. So let's do some examples that involve indeterminate forms. So for my first example, I have the limit of x minus 2 over x squared minus 4 as x approaches 2. If I start with direct substitution, I do end up getting a 0 over 0, which is an indeterminate form. Before we go on, I actually want to point something out. So for the AP test, if I write something like this is actually not an exactly true statement, because the limit is not equal to 0 over 0. So rather than writing it like this, there's two other things that you can do. The first thing that you can do that you probably, many of you might prefer, is you can just cross out the stuff that you wrote. The better thing to do is to write the limit of x minus 2 as x approaches 2 is 0. And you can write the limit of x squared minus 4 as x approaches 2 is 0. You can write it like that if you would like to. You do not need to write all of this out, but just keep in mind that if you write that 0 over 0, it's not a completely mathematically valid thing to write, so just beware of that. If you do that on a test or quiz, I'll probably mark off like a half a point or something, but on the AP test, they actually do dock points for that, believe it or not. Okay, so sorry I got sidetracked there, but that was something important that I needed to mention. So for this example, we do have an indeterminate form. So rather than just saying it doesn't exist, because it actually does exist, we're going to use another method. If you notice on this one, you might recognize that this graph actually has a hole. We can find that it has a hole by factoring. When you factor, you will have some factors that cancel out. So in this case, my x minus 2 and my x minus 2 cancel out. So I actually can rewrite this as the limit of 1 over x plus 2 as x approaches 2. Now I can use direct substitution, and when I use it, I get 1/4. So this actually is my answer for this. If you were to look at the graph, you would find that it actually has a hole at x equals 2, but it is continuous at that value. So in this case, we used factoring. That is our first method if you get an indeterminate form. And by indeterminate form, I mean a 0 over 0. So for this one, what you're going to find is as you work this problem out, you will end up starting out and getting an indeterminate form. So you need to use other algebraic methods for this. My first inclination for something like this, if I see something like 4 plus h squared, I would actually expand that out. I would use the FOIL method. So I'm going to expand that out. By the way, you might notice I almost made a mistake on this. Make sure that every time you write out this problem, you include the limit. It sounds really annoying because you do have to write it all out, but it's just a good habit to get into. So, okay. So now I am going to multiply this out. I end up getting 16 plus 8h plus h squared minus 16 over h. Actually, this one, I am going to be able to cancel some things out. You might not have seen this right away, but if you get a 0 over 0, just know that there's usually something you can do to solve it out. So I end up getting this. Now, with that, by the way, if you see what to do, you could feel free to skip this next step. I can factor out an h in my numerator. Sorry, that should not be an h there. So it should just be h times 8 plus h all over an h. Now, these two things are going to cancel out. I end up with the limit as h approaches 0 of 8 plus h, and that just gives me an answer of 8. By the way, just a side note on this question, you may or may not have noticed, but this is a difference quotient problem. You'll see these a lot, by the way. So this type of problem is interesting. It actually involves something you probably learned back in Algebra 2. You'll notice that if you substitute in 0, again, we're going to get a 0 over 0. This one is not as easy to multiply out as the previous one, and there's not really any easy way that you can factor. However, one thing that you can do is you can rationalize. So rationalizing can either occur with the numerator or the denominator. What I mean by rationalizing, I mean that we're going to eliminate the radical. And we do that by multiplying by its conjugate. The conjugate is going to be the radical with keeping the same sign, but then our other portion of this expression is going to change signs. So that 5 is going to become positive. I have to do the same thing in the denominator because with math, I can multiply by 1, which is something divided by itself, but I can't just multiply by a random radical x squared plus 5 plus 25 plus 5. So I'm going to rationalize this out. I recommend that you pause and do this on your own. So when you work this out, we still keep our limit sign there, by the way. I end up getting x squared plus 25 minus 25 all over x squared times this really ugly expression. I highly recommend on this next part, the ugly expression on the bottom, don't multiply it out just yet. Keep it in the simplified factored form because you might have stuff that you're going to do with it. One thing you might notice is that my numerator is going to change to just plain old x squared. And now something really nice is going to happen. The x squared in the numerator and the denominator is going to cancel out. So now I am left with the limit as x approaches 0 of 1 over the square root of x squared plus 25 plus 5. If I substitute that 0 in, I end up getting 1 over 5 plus 5, which is 10. And that's my answer for that one.